This is part 2 of the section 2.4 mini lecture. Now we're going to talk about the properties of multiplication, which are very similar to the properties we had for addition. So first of all, a set of whole numbers is said to be closed under multiplication if whenever A and B are in the set, then A times B is also in the set. So there's no way to escape from the set by multiplying. It's very similar to what we did with addition in the last section. Okay, now the set of whole numbers is itself closed under multiplication. A whole number times a whole number is always a whole number. Okay, you know that from grade school. You know that every whole number division problem has an answer. Every whole number multiplication problem has an answer. But when you first learned division, you might remember that not every division problem had an answer, not in the way that you first viewed it in school. So, what we're saying there is that the whole numbers are closed under multiplication, but they are not closed under division. Every whole number multiplication problem has a whole number answer, so they're closed. And that's called the closure property of non-addition multiplication. That's a typo. Okay, so second, given two whole numbers, A and B, it is always true that A times B is equal to B times A. This is called the commutative property of multiplication. Okay, you can remember it in the same way that we discussed for the commutative property of addition. The two numbers are hopping in their little cars and they're driving past each other. Okay, so for example, 3 times 5 is 5 times 3. This is best illustrated using the area model, or maybe the array model. I can take a 3 by 5 rectangle, which represents 3 times 5. I can turn it on its side, and that would represent 5 times 3. Okay, but of course the area is equal in each case. Okay, this is the commutative property. Okay, next we have the associative property, which is similar to the associative property for addition. When we write something like A times B times C, we're not really allowed to do that literally because we can't multiply 3 numbers at once. We can only multiply 2 numbers at once. Okay, but the associative property tells us that it doesn't matter which 2 numbers we start with. We will always get the same final answer. And rather than try to draw this, I'll just show you the picture in the textbook, which is on page 105. Okay, so this shows that 4 times 3 times 5, with 3 and 5 in the parentheses, is the same as 4 times 3 in the parentheses times 5. So the stack of 4 3 by 5 is the same as this row of 5 4 by 3s. Okay, they both get put together into the same solid figure, 4 times 3 times 5. Okay, so that's the associative property. Okay, and next there is a unique whole number, which we call the number 1, so that A times 1 is equal to 1 times A is equal to A for every whole number A. And this number is called the multiplicative identity. So the number 1 plays the same role for multiplication that the number 0 plays for addition. Okay, finally, for any whole numbers a, b, and c, a times b plus c is a times b plus a times c. That's called the distributive property. For example, 4 times 3 plus 2 is 4 times 3 plus 4 times 2. And this is best illustrated using the area model. 4 times 3 plus 2, that's 4 times 5. Let me draw a 4 by 5 rectangle on one side. Okay, but we can break that up into 4 times 2 and 4 times 3. Now, notice how I'm drawing this. I'm drawing it so that it lines up. So there's our 4 times 2. We're adding that to the 4 times 3. And the way I have it drawn, I can see really clearly how if I just kind of scoot the two figures together, it'll form the 4 times 5. Okay, so the way I have this lined up here is important in this kind of drawing. And it's the distributive property that leads to what you might have called the FOIL rule in grade school or algebra class. I recall that when I was taking algebra in the 8th or 9th grade, I had a really hard time with it. I was actually a solid C student. And one of my big hang-ups was not understanding the role of this FOIL thing. It just made no sense to me. But it's really no more than the distributive property applied twice. I just didn't get it. And maybe it's because I didn't adequately understand this more elementary property that I should have learned very well in something like the 3rd or 4th grade. Okay, and I think pictures like this really help you understand why it works. And you can do things like this for the FOIL rule, which you will explore in the homework. Now, here's some terminology that you would use when you're speaking out loud in front of a classroom. If you go from something like a times b plus c to a times b plus a times c, that is called distributing the a. Like up here, I distributed the 4 to the 3 and the 2. It's like you're passing it out to everybody. If you go the other direction, from a times b plus a times c to a times b plus c, that's called factoring out the a. So if you go the other direction, you factor out the a. So if I'd started with the right-hand side and then I wrote it like the left-hand side, I'm factoring out the 4. Either way, it's the distributive property. So it's the same property, but you refer to its usage in 2 different ways. Okay, then here are all the properties of multiplication. We have the closure property, the commutative property, associative property, the identity property of 1, and the distributive property.